Hello teammates, it's Mr. Nini coming to you with a physics bunker production looking at the solution for FRQ, I think it's number 5. My numbering system is off. I'll make that straight. I hope you're not too frustrated with that. I know you're going to be a little frustrated. I'm off of my numbering system. I'll try to get that right in the next couple days. What you hear when you hear the phone go off, just so you know, the science team has got a group text, and so when you hear that go off, so we're texting all day long on how we can troubleshoot, how we can produce high quality instruction for you, and so I think that's what makes the science team powerful is our ability to communicate. So when you hear that go off, in fact, I can be smarter. I'll turn that on buzz. There we go. Hot dog. Well, you didn't need all that. Let's look at this problem. Nice. It's a roller coaster, but you've not dealt with the loop yet. And it helps me reinforce something. When you're faced with something on the exam you haven't seen before, you got to steel yourself for battle. You cannot panic. You can't say, oh my gosh, I haven't seen this, I can't do it. Bull crap. You're going to apply your physics principles, and you are going to solve it. Got a roller coaster. We got a mass, point A. We're given a height. It's going to roll without negligible friction. Recall, you can ignore friction. It's going to go around the loop, and the loop's got a radius of 20 meters. Point B, the highest point on the loop, we're given that. It's a roller coaster problem with a twist, with a little uniform circular motion. Easy money. You're going to read the whole question. Indicate on the figure the point P where the maximum speed of the car is attained. Value of Vmax. Calculate VB at point B. We're going to do a little free body diagram. Magnitude of all forces. And then we're going to be given a change to the situation where we now have to consider friction. What are we going to do about that? Let's attack. One thing, so again, I was on a call last night with the college board, and they laid out the test construct. It's a new thing, so don't be frustrated. I'll digest that for you, and we'll have a conversation. But on this problem, I know probably at some point when you look at the key, when I get to that, it says U sine G, comma, G equals 10 meters second. Now again, don't panic. You're going to, what the heck, U sine G? I never heard. It's a typo. Using G equals 10 meters second. Right? So just be at peace. And all shall be well. I had a student 2 years ago said a very effective technique during the exam is just imagining me whispering in your ear, you got this. And they said that got them over the top. They got at least a 4 that year. So indicated the figure point P, maximum speed, easy money, energy conservation. It tells you it starts at rest. You're going to convert all these 90 meters of gravitational potential energy to kinetic energy. There's your greatest velocity, easy money. But again, you can say point P, but you gotta put some words on it. You just can't say P. It's not a trap. They're expecting you. Well, it's sort of a trap. They're expecting you to say, oh, I got my point P. You got to say why. Point P because energy is conserved and UG is converted to KE as the cart goes from point A to point P. It's good. 2 points. Calculate the value of Vmax at this max speed. Easy money. You're going to set up energy conservation. So energy is conserved. It's a trade-off. Energy, we got potential and kinetic. Energy is conserved. Your gravitational potential is going to convert to kinetic. you gotta at least, I would go there, then put your variables in, then you solve for your variables, your Vmax. You gotta do this. You're gonna get tired of me saying this. No miraculous solutions. If you write this and then this, you risk throwing away a point. They want you, there's only 1 point for double I, which was interesting to me. You gotta walk the dog. Step by step. We can't see. Step by step by step. I get so excited, I just focus on the paper. I forget it's not in the screen. Hot dog, easy money. Now we're gonna, so that, I ran this over here. There you go. Now we're gonna calculate the speed of the car at point B. Now you're gonna say, whoa, what the heck? Energy conservation, teammates. So you know if you had gravitational potential there, you had kinetic there. This kinetic's going to be converted to some gravitational potential and kinetic there. No friction. Easy money. You can also solve this with the difference, and this is what we're going to do here. You can also solve this with the change in y to that. It just becomes a different problem. Right? So you've got UG. I need to name a character Eugene. I don't know how I've gone so long without. I missed an opportunity. So UG initial equals UG B. Let's call it UGA. I think they like that better. UGB plus your kinetic energy at B. It's an energy conservation problem. Now you can attack it either way. If you get your kinetic energy there, and you do this, kinetic P equals UGB plus KB. You're going to get the same thing. Exact same thing. Remember that path independence of gravitational potential energy. Doesn't matter how it gets there in the absence of friction. It doesn't matter how it gets there. It's just that change in Y. So I did it two ways, and I just ran out of room, so I redid it so it's cleaner. I used this technique. So my gravitational potential energy, I gotta call that A, sorry. At A equals my kinetic energy B plus my gravitational potential energy B. Teammates, they like the subscript. They want to know that you know you're talking about a specific point, not some velocity in general, but a specific point. And then you're going to rearrange. You're going to solve for a little algebra, solve for B. 2g times the difference in height, right? Because you're gonna lose some gravitational potential energy, and that's where you account for that. Then you're gonna put your numbers in. Then you're gonna solve. Two decimal places. It's good. Let me talk about this too, because I know this has got some teammates wound up. Because you look on the key, it says 9.8. Teammates, don't fret. Some people get really upset with that. My gosh, we're not being specific. We didn't use 9.8. Oh, bull crap. Look on the exam what they want you to use, and you'll see if you read the solutions, they're going to give you an option to use 10 meters second. They're looking at your ability to reason through physics problems, not your ability to work your calculator. It's good. Hot dog. On the figure of the car below, draw and label vectors. Uniform circular motion. Your net force is towards the center. You got to reason through, and that's why I put this. My goodness, I'm out of frame again. You don't put this on your exam, but I want to reinforce this point. On the feeler by the dealer. Recall, way back, my goodness, September, we identified a force as an interaction between two objects. A push or a pull, interaction between two objects. So you analyze this, it's a trap, right? Because they want physics students who really don't know physics, they just know how to repeat a pattern to draw that normal force up. right? Because normal force is always up. Nah, it's not. On the feeler by the dealer. Look at, sorry. Look at what, so here's your cart, it's upside down, there's the rails. You've got a force gravity down. You've also got a force normal down. That track is going to apply a force on that cart, but in the down direction. And so you can draw your free body diagram. You can stack your forces, or you can draw two separate forces. But recall, every force gets their own vector. I should put that too, so don't get 2 points. 2 points to identify the force gravity, force normal acting down in both cases. 1 point for no extraneous forces. So they're going to take a point from you if you draw. I'm not going to actually draw it. If you draw a force vector, if you draw a velocity vector as a force vector, again, ask yourself, what are the forces on the feeler by the dealer? So here, they like this too. They want you to set up, they're going to ask, calculate the magnitude of all forces. So I would say, I thought I wrote it, apparently not. This is a centripetal force problem. Thus, force centripetal equals force normal plus force gravity, right? Force centripetal is your net force down. You're going to solve for the forces. Force normal, we're just going to algebraically rearrange. Force normal equals force centripetal minus force gravity. And then they want you to do this. They like you to do this. Put your variables in. Force centripetal, mvb squared over r minus mg. Can't cancel masses, right? You have no mass on this side. You can't cancel your masses. Yeah, and then put your numbers in, right? 1 point for identify it's a centripetal force situation. I would be explicit and state that. 1 point for setting up your equation, and 1 point for solving it. And again, I know many of you have been burned in math class when you said the answer was 20,440 and your teacher said it was 20,441 and you got it wrong. That's just stupid. So, because it just makes you afraid, right? It's just stupid. So let's proceed. Let's proceed. Last step. Suppose friction is not negligible. So you're going to write a statement. This was 2 points. So if you've got friction, here you got your gravitational potential going all the kinetic. Here you got your gravitational potential minus your work non-conservative. So you're going to end up with less velocity there. You're also going to lose, because now you got kinetic being converted to kinetic and gravitational potential. You got less energy going into that gravitational potential to get you up. So if you've got friction, write a statement. I didn't do a terribly good job of modeling for you because I'm trying to get this posted. Don't just say, how could loop be modified? Make it smaller. Justify. If it was smaller, it could do it. That's not a justification. Right? You got to lay it out. Claim, evidence, reasoning. So you could approach it. You got, if friction, you got less gravitational potential to convert to kinetic. Or that I did it from point A, I should have said. If you hear you say you got less, you're going to lose kinetic energy to friction, and you're not going to have as much to get the height of